Hello, and thanks for listening to the Biomass Magazine podcast. I'm your host, Anna Simet. I hope all of you are doing well. Today, our guest of the hour is Cornelius van Tonder, Chief Technology Officer at a company called Regen Corp Global. Cornelius, welcome to the podcast.
Thanks, Anna. Thanks for having me. I really appreciate the opportunity.
Well, we're really glad to have you. So, why don't we begin by having you tell us a little bit about your background and then the basics of Regen?
Yeah, so I'm a chemical engineer by trade. I spent my whole career in the energy sector. South African citizen, used to work for power and utilities company, started a engineering consulting firm a couple of years ago, and then moved that to the US and partnered here with Regen, for who I function as Chief Technology Officer. So Regen Corp, as a company, we're truly passionate about access to energy and providing energy into rural community and waste to energy. And we have a suite of technologies in both pyrolysis and gasification that is commercialized elsewhere in the world. And we're pretty passionate about what we do. We're passionate about access to energy, and we're passionate about empowering farmers and local growers.
Perfect. I think that's a good segue into my next question. So your technologies, you mentioned pyrolysis, gasification. For our listeners who don't know, can you explain the differences in the processes and then, the end products they produce?
Yeah. So both pyrolysis and gasification, the similarities between them first, they're thermochemical processing or thermochemical conversion processes. Pyrolysis is oxygen depleted environment. It's an environment without oxygen. Gasification, there's partial degradation with oxygen. In both of these technologies, you get different applications of that. So you get the standard rotary pyrolysis kiln that just produces a biochar, a syngas, and a wood vinegar or a bio oil. In our case, we have a shaftless screw, a pretty unique pyrolysis system in which we produce biochar, a little bit of wood vinegar, and a clean syngas. Gasification, you get also various types of it. Gasification, typically most gasifiers do not produce a solid residue or a biochar. It's more production of syngas. In our case, we produce a biochar. We have about 85% solid reduction percentage, meaning that 85% we gasify becomes gas, and we produce a 15% biochar. The applications as well in both these technologies, pyrolysis is typically more suitable for smaller scale, 1 ton, 2 ton to 4 ton per hour applications, whereas gasification is quite larger, up in the 10 ton per hour range. So different needs, but quite similar.
Okay. Thank you for that great explanation. So you had mentioned a big focus of yours is baseload power in rural communities. Can you give me some examples of scenarios or locations where this model would be ideal or beneficial?
Yeah, so actually, since the Biomass show in March, we've had a large focus in small town communities, in specifically Alabama, where we're looking at populations less than 3,000, with a end of the line grid connection or a privately owned grid connection, or behind the meter requirement for more stable grid power. Up to 2 megawatts or 10 megawatts. We're pretty scalable. And we found that there's a great need in the US specifically, and for these small rural communities to have a baseload sustainable power generated from their waste. So in an ideal scenario, we see these communities have to either there's waste that's just laying on the fields, it needs to be transported away, there's a cost that comes to that, it's either incinerated or burned in the field. And that is basically taking energy they do have, which they can utilize, and just they lighting a match to it, right? So we've identified quite a number of opportunities within the US, and we started rolling this out specifically in Alabama, and that initiative of ours have taken quite a quick approach, and we've garnered a lot of interest. For example, as well, yesterday I spent some time on a reservation, where the reservation is basically the closest that they're connected to the grid, but they're right at the end of the line. The power production is 300, 400 miles away, and it's serving all the communities before it gets to their small town. They have grid instability across the board. But one thing they do have is they have within their agricultural lands, they have low density waste like rice straw, wheat straw, and these things that's definitely not being utilized at all. So that's definitely an initiative that we're passionate about in terms of giving communities access to energy and valuable commodities out of what they do, because the biochar we produce from the system can either go back to the farmer, it can be sold into the market, it can be used for soil remediation. There's so many benefits. So that's a little bit about the Rural Community Initiative.
Okay. Cornelius, can you tell us more about how you partner with farmers and foresters?
Yeah, so that's in the name of the business, right? Regen, meaning regenerative. We're like a full circular approach, and we have under Regen Corp Global, we have a company called Regenerative Ag. And within that, we like to partner with farmers for the long haul and growers and foresters in terms of offtake agreements for their biomass, and then also giving them products back and letting them take part in the projects as a whole. That's a model where we've seen it best works in terms of ensuring long-term offtake and long-term community value, both to the farmer, the community, and the project stakeholders as a whole.
Okay. So could you tell us more about your projects? What have you done? What do you have planned? I saw that you have a crop residue map on your website with some potential project sites marked. Can you tell us more about that?
Yeah, what we've done is quite elaborate. So we started by designing out full system, a large-scale gasification to renewable natural gas system. I went across the whole world to seek for commercialized technologies, and found commercialized technologies within that space that we licensed to the America. So we're the exclusive license holder for those technologies. And then we developed from that. We developed the electricity program, which is currently running offshore. It's commercialized, fully producing electricity from waste. And then we developed the smaller scale systems in terms of pyrolysis, and that's mainly systems that are fully commercialized on indoor ag applications. It's taking biomass to support CEA applications and producing biochar that goes back into the greenhouses. Projects we have developed onshore and are in the process, and hopefully we will close fairly soon on that, is number one, the small town initiative, which we've already discussed. Number two, we have developed biomass to large-scale biomass to electricity for data center off-takers, preliminary in the Gulf, and that's what you see there on the map, with a potential offtake into fields. So we have within our portfolio of technologies, we have a pathway to go to methanol and a pathway to go to RNG, like I mentioned. And then we've done extensive work within the US rolling out all these RNG projects, which is something we're long-term very passionate about, and as well as these methanol projects. And then another area of focus is the Caribbean and small island nations. And that comes back to our view of access to energy. So you sit with communities that truly do not have access to any type of fossil fuel or any type of reliable energy. Solar and wind gets incentivized but cannot provide them with baseload power. And you sit in some of these communities and island nations we've spent some time with. You see large agricultural residues being just burned and incinerated, and there's no gas cleaning or any control regarding that. So we've spent quite a lot of time for project developments in there. And our firm belief is that by beginning of calendar year 2026, we will start breaking ground on projects in the continental USA and within the Caribbean.
Okay, that's exciting. So Cornelius, what about MSW? It's a bit of an unconventional feedstock. Does it have a lot of potential in what you're doing?
Yeah. So one of our commercialized sites offshore, it's running in Turkey, is actually running on a municipal solid waste. It's not running on a landfill. So basically, our technology, our gasification technology is pretty robust. It is fully commercialized, been running since 2020 on a landfill. It's an interesting case study where the current plant is, because it's a migratory waste problem and that's initially how that project was originated. During half of the year, the population grows by 50% in the community because of tourists flocking into the area. And they had all this excess waste and landfill capacity running out, and they needed something to do with it. And they understood that incineration is not the right path for it. So yeah, MSW applications works well for us, and been sitting with communities and with PRO and with everybody to see if we can sort of find a way within North America to do MSW, still get it classified for carbon credits and add that value to it, because it's definitely a feedstock we can process, and it's a feedstock we like to process. So yeah.
Okay, great answer. So my last question for you is, why aren't there more biomass gasification and pyrolysis plants in the US now?
Yeah, so I think that's a really good question. And my honest answer is, I think, number one, that so many has come to this hill and failed. And I think it's created a bad perception for thermochemical technologies, right? And number two, I think a lot of technologies has come and on this scale has not been able to or deliver on what they promised. So to be quite honest, I looked at over 40 companies in terms of technologies across the world. And out of the 40, 35 of them was thermodynamically questionable, meaning that their auto consumption is too high, the feedstock flexibility that they can take was too low, meaning that if the moment the feedstocks start to vary, they start to clinker or they start to slag. And there's well-known, well-publicized projects within the US that failed for that exact reasons, right? So what we should also consider under gasification, it was commercialized. Initially, the technology came on from large-scale coal gasification, which is a very dense feedstock, right? It's easy to handle, and it was up to, currently there's running systems up to 1,000, 2,000, 3,000 tons a day. In terms of biomass gasification, that becomes a little bit difficult or different things to handle. And I think that the technology that has come to the North American market hasn't necessarily been as commercial as people thought. And yeah, that was one of my main aims, was to bridge that gap, to find technology that is feedstock agnostic, that can truly be flexible, and that has commercially been proven on these data sets, and as a efficiency that starts to make sense without incentives, right? And because that's something within the space that we're missing. We need thermodynamically sound solutions that we can take to market that is not heavily reliant on incentives. And yeah, that's another thing we've seen here. So To summarize my views on it, I think number one, perception and the types of pyrolysis and gasification solutions that has been presented to the market. Yeah, I think that should summarize it. Yeah.
Okay. Well, that's a really great, honest answer, Cornelius. I really appreciate that. Before we wrap things up, is there anything else that you want to add?
Just in general, to summarize everything we're doing, I think it's a great time, it's a great space to be in. This is really something we're passionate about. And I think if one looks at the gasification and pyrolysis and thermochemical processing in general, it truly is a better, more alpha, more sustainable solution than biomass incineration. And the technology, our technology definitely are there, are competitive, and are at a lower capital cost than typical biomass incineration. So yeah, I think it's a great space to be in, and I think there's great opportunity here, especially gasification. As for me, I view it as something with a very bright future, because if you can successfully convert low density feedstocks into a clean syngas, that's the building block for fuel pathways. You can expand into methanol, DME, RNG, all that becomes viable and economically feasible options. And yeah, so yeah, and and then I think from my side, just I really appreciate the opportunity to speak about this to you guys today. And yeah.
Yeah, thank you so much for coming on the podcast and telling our listeners more about Regen and what you guys do. And we sure look forward to following you in the future.
Yeah, perfect. Thanks, Ed.
Yeah, thanks so much. And to our listeners, that was Cornelius Van Tonder with Regen Corp Global. Thanks for tuning in, and we'll see you next time.